dance.
This is how I interpret overflow my fist with his face.
Don't try that. Or you can try and interpret spam live. Perfect dance.
Spam live.
Free bird! Who's got a lighter? No, there's no playing Led Zeppelin.
Hey, I don't know.
Hey, mine's got spam. Is this a shot?
Sweet.
Sure.
What's a sure mean?
If you want to chug it, chug it. You can try it, I'll take yours.
Okay, you're live.
Beautiful. All right, welcome to Zen and the Art of the Turing Machine. Does anybody have a clue what this talk is about, based on the abstract?
Zen and the art of...
That guy in the front. What?
It's about tour.
About tour. Okay.
It's bacon.
Magic.
This note, does anybody know what this measure means? Bam. In the front. Bach. Yes, it's J.S. Bach. Anybody who's read the fantastic book Gödel, Escher, Bach may know. It's from his last work called Art of the Fugue. It is a contrapunctal, which means that you have two notes that are playing against each other or two melodies which are playing against each other. What's very interesting about this particular measure, the way in which the Austrian score was done, the H is actually like a G, was it a G sharp or something like that? Which meant that the last measure, he actually wrote his own name, B-A-C-H, within the music. And it's cool just because it was the last piece of music he ever wrote, and he actually died shortly after writing it. See, pedagogy would be the understanding of how we learn, and the most primitive concept of how we learn is through symbols. Right here we have axon and a dendrite, but what are some kinds of symbols that we might use? Like alphabet, perfect. What's the first thing that a child learns? Anybody here have kids? No, nobody has kids.
I have a husband, does that count?
You have a husband? Yeah, same thing.
Basically.
But the first thing that you teach a child is the numbers and the letters of the alphabet, because you can eventually use those for self-expression. You can turn these into language, because when you take letters and you can mix them up into words, and eventually you can use them to formulate thought. And this goes into thought organization. As a child gets older, as we see in the school model, where a child in kindergarten is learning the bare basics, and as you get older and you go through the grades, you are introduced to more complex subjects. You can't teach algebra to some kid who doesn't know any arithmetic, but somebody who knows arithmetic and understands the symbols and how we understand them is able to then interpose them into an algebraic system. Goes back to Plato. Who knows what this is?
Rosetta Stone.
Rosetta Stone. What is the Rosetta Stone?
Something that English stole from the French.
This is true.
They sell an airport.
It's an alien practical joke.
It's a really hard third.
3 copies of the same text in different languages.
Bingo.
That too.
It was created in 196 BC, discovered by the French, stolen from the French by the English, and it contains 3 different languages which have the same passage. It has hieroglyphic, demotic, and Greek, which are basically 2 Egyptian languages and a Greek languages. And by taking the passage within here and comparing the text and the symbology, they were able to then decipher many more things which were written in hieroglyphic and demotic. It's very important for that.
Demonic?
What? Demotic.
Oh, okay. They're little evil Batman people? Okay.
Sure. But how might this be, how could this be important? It helps you to bridge a language barrier, a language gap. Does this look familiar to anyone?
Adam?
Adam. This is Genesis, where Adam is naming the animals.
You're so smart.
What?
Didn't have pictures.
What? And he's naked, too.
So are all the animals.
What? All the animals are naked. Yeah, have fun animal sex. But what's important about this is that Adam is taking these animals, which had no name, they had the name that God gave to them effectively, and by using the name and the nomenclature and the symbology, he is thus able to take a control over them. For example, say you have a cup sitting on a table. You have a cup, you call it a cup. If you didn't call it a cup, then you wouldn't be able to identify it from the rest of the table. So by using language and the symbols... What? Why is that?
Yeah.
Even if you're pointing at something, the point represents a symbol that you use to take control over an object.
Why is it that by giving the cup a name, you can separate it from the table?
By giving it a name, you can then take the idea of the cup that is there and give it to somebody else.
What if you have a table shaped like a cup?
What?
What if you have a table shaped like a cup?
Like
You could
a-
say that thing on the table. You don't have to mention it by name.
This is true.
It's the same thing, right?
What happens
Right,
if
right,
you
right.
give the wrong name? You assign a value.
A name is an idea of a symbol.
What if you give it the wrong name?
Give it the wrong name?
Yes.
Why would you give it the wrong name?
All names are relative.
Right, names are all relative.
So where does the cup end?
What?
Where does the cup end? The thing on the table.
The identifier of the cup, where does it end?
No, where does the cup end and the table begin?
Ah, beauty's in the eye of the beholder.
There is no cup.
There is no cup.
There is always a wall.
He's gonna hate it.
Okay. So this was a poor attempt to try to find an idea like the circle of life within the jungle or whatnot. You have, after all the animals have been named, they can then use other characteristics of themselves to compare and contrast. So the lion is the king of the jungle, and what characteristics do lions have that make them supersede over all others?
Sunglasses?
Big mouth.
Awesome hair.
Awesome hair?
A loud
Love
roar.
of tacos everywhere.
The women do all the work? Wait. Was that the wrong meaning?
Wasn't it his roar or something that traveled over the land or some bullshit?
What?
Wasn't like his roar or something that traveled over the land or some bullshit?
Right, well, the idea is you have an animalistic social system that formulates itself based on the strengths and weaknesses of all the animals. Darwinism effectively taken command.
An animal.
Does this look familiar to anyone?
Mom?
Linnaeus. Famous for his nomenclature, Kingsblake cards on fat green stools, kingdom, phylum, class, etc. And what? Kingdom, phylum, class, order, what is it? Family, genus, species.
Hey.
Indeed.
Have another drink.
None of us know if you're wrong. None of us know if you're right or wrong now.
Make that clear.
But like Adam, his work is important because you have the structure of life within the animal kingdom, and with the genealogy that he creates, you are able to then sort animals, and you are able to take more control over them by determining how they are sorted, which classes they are sorted into, and whatnot. Question?
Not actually controlling the animals, though.
You're controlling your perception of the animals.
Okay. Very different.
Very.
Not much.
Oh, that's Gondor.
Okay.
He who rules the spice controls the world.
The spice melange. Okay, does this look familiar to anyone?
It's Gondor.
Babel, yes. Why is Babel important?
Because it got owned
How did Babel get owned?
by God.
By God. How did God own Babel, though? And that's where it gets...
Knocked it down.
Is this godlike?
No, God...
He's like, you
Yes?
don't know God. Changed the voices.
Everyone up to that point spoke one language, and they were building a tower up to heaven, and that was displeasing to God. So he smote them, and they all spoke different languages and couldn't understand each other.
Exactly.
If they learned how
Right
to draw,
answer.
they wouldn't have had a problem.
So have you just read Stoker? Just wondering.
But no, it's precisely what it was. And language allows people to communicate, and with communication, you have collaboration. Thus, they were able to build a structure trying to fortify and achieve what God was, and trying to reach the stars in the heavens. And with lack of this communication, the whole thing fell apart. And it's also the biblical story of how languages came into the world. Does anybody recognize this?
Mom? It's an Enigma machine.
Yes.
A three-wheel Enigma machine. It's a cheap.
I know how to turn it on and press the buttons.
Yeah. Have you ever played with one?
Women or the money machine?
Both. One is more fun. I'm not going to say which. They're both just about as, well, they both have buttons.
Women have nicer buttons.
I don't know him.
But the enigma represents the idea of cryptography, taking somebody's language, somebody's ideas, and restructuring them into another language system that is harder to understand because it creates a barrier. It creates a cryptographic system. And it's very difficult to bridge this unless you understand the method by which you attain and jump over to become that system. And we'll get into that more later. Does this look familiar? Yes, it's the printing press. The phrase in question here, a time when dogs could talk. There's a Pulitzer Prize-winning author, N. Scott Momaday. He gave the commencement speech at St. John's College last year, and the premise of it was oral tradition and dealing with what happened with oral tradition and how it became changed by the printing press and subsequent technologies and how that affected social systems. So he gave 3 examples. We had Beowulf, Hamlet, and the Gettysburg Address. Why would those matter? Anybody?
Why not the Old Testament?
What?
Why not the Old Testament?
Beowulf is older
Okay.
in the English language. Beowulf is the oldest.
So it's Old English, Middle English, and Modern?
It's Old English and then the Renaissance.
Shakespearean English.
Yes, Shakespearean. Hamlet is considered the finest of Shakespearean English.
Right. It's not exactly Old English.
Well, it's Old English as transcribed through the ages. Beowulf started out with oral tradition and oral history, the poetic sense. One of the reasons being because there was no easy way to write things. At certain points, there wasn't even writing. Writing hadn't been developed yet, but people needed a way to communicate ideas, preserve historical mythology. We'll get to that.
But the Bible was both oral tradition and then Shakespeare put it into...
It is.
The Bible was oral tradition until...
Yeah,
like parts were written down.
Absolutely.
It was reconciled in like 500.
and then Shakespeare brought it together for the Anglican Church.
That was for, God, was that the King James translation, wasn't it? Yeah.
When King James needed a Bible for the Anglican Church.
Right. Henry VIII. Well, it was after Henry VIII. Yes.
We just have one person presenting ideas instead of the entire front row, because I'm fucking old.
Well, it's a
Okay.
panel, that's all of it.
Oral tradition, you have ideas interposed, right, and those ideas change. And the way that society communicates those ideas also changes. What makes Hamlet different from Beowulf? Time is one thing, but with
Beowulf gets the chicks.
Beowulf, you had a story which is already developed within oral tradition. And when you write it down, it assumes a form which is more difficult to change because you have that solid structure which is then preserved through time. Whereas Hamlet took the Shakespearean idea of writing and it experimented and explored with the concepts of writing. And Hamlet is generally considered the finest of Shakespeare's works. Hamlet being, well, from oral tradition, it's a very old story. Yes?
So wasn't Hamlet performed by play actors and refined through the ages, much the same way that Beowulf was told by minstrels and galleries?
Exactly.
Yeah.
Mm-hmm. The Gettysburg Address represented Lincoln trying to keep the people of the U.S. together because they're dealing with a very serious time of conflict and dealing with how the social systems were intermingled, trying to rejoin them, telling everyone to look to our past to try to understand the differences and how we were able to overcome them. Control of objects. Now that we understand what an object is, we have the name identified with it. You then have the concept of object-oriented programming, where you have an object like a square, like a triangle, and you are able to then point at that and manipulate it. This particular example is from the Shirtley project from Terry Winograd, MIT in the 70s. And you have a person communicating with the computer. The person says lexical words, pick up big red block. So suddenly you know it's a block, it's big, and it's red. And you can interrelate that with all the other objects that are there. For example, if you say to pick up the little red block, then there's a green pyramid on top of it. So the program sees this, and it uses the language structures that we have relating these ideas. And it says, hey, there's a green pyramid on top of that, so we can't move that unless I want to move the green pyramid first. This is the Shannon-Weaver mathematical model, which goes into the idea that words are an encapsulation of meaning. You have the information source, the transmitter, and the channel. The channel would be the communication between two people. So information source could be, I see something and I want to share the idea with somebody else. So I see a picture, so I say, hey, there's a picture of a dog. And I know my friend likes dogs, so I say the words, I see a picture of a dog. I tell him that, goes over the communication channel. He receives that, and he's able to use his understanding of the words and how they relate to something I might be saying to understand his own context and my own context. Does anybody, how would this relate into what we've discussed so far with language and using language as tools? Yes?
We're basically breaking down like a signal and discussing the different points of
Right.
basically entropy in the signal and how we're going to reconstruct or interpret said signal.
Exactly. Just like you were separating the cup from the table, in this case you were able to use language to not only separate objects from each other, you were also able to take that idea and communicate it to somebody else, and that's very powerful. Using those ideas, that's how they were able to construct Babel. And this is also the basis for OSI and networking structures. This is also the basis for education and teaching children. When they understand the bare basics of language, how words work, how they're spelled, arithmetic and whatnot, a child is able to grow up in a society that is based on these languages and understanding thereof.
But more importantly,
Yes?
what about Eve?
About Eve?
Yes.
Ah. Because this goes on the flip side too. Because within cryptography, you have a channel going across and you want to make that channel secure. So if I am English and I am speaking speaking English ideas, and somebody who is Asian, say Chinese, is trying to understand these English words, they won't, because they don't understand the language, they don't understand the letters being used, so they can't even use romantic ideas to interpolate what it is that I'm saying. The idea of using context is something else that we'll get to soon.
So basically, you're the information source, that guy's the destination, and we would be the noise.
No.
Yeah.
Oh, we would be Eve.
Oh,
No.
What's an entropy?
you are!
Entropy is the amount of chaos within the system.
Chaos.
Well,
Chaos, what is chaos?
It's over here.
Signal to noise ratio. Say you're listening to a radio and you hear static in the background, but you also hear words going across. You hear the football broadcast, right? So how is it that you're able to hear the football broadcast, though? It's because you're able to pick up frequencies that you interpret as words, and you can take those words and interpret that within the context of the game that you're listening to. You can take the words and symbols that you're getting, interpolate that with everything else that you've been hearing before using that prior context and prior history. And you can understand what is going on instead of having it be in a bunch of noise. SETI has to deal with this all the time, trying to listen into the heavens for whatever sign of alien activity there might be. The book went into a great detail on that, where they had they were communicating prime numbers through signals and trying to find a message through the prime numbers.
so how would Eve be able to determine the noise? How would Eve be able to separate the noise if it doesn't understand the pre-agreed upon protocol?
How would Eve be able to understand the noise without understanding the pre-agreed upon protocol?
How would Eve be able to separate the noise?
Like right after God's messes with the Tower of Babel, like no one speaks each other's language anymore.
One of the problems with trying to encrypt a message, and this is assuming you're trying to hide something, is that there are inherent patterns within language that are nearly impossible to wipe out of the message stream. One-time pads are the closest that we have to that, even though there are no true one-time pads. It's not true?
Why are there no true one-time paths?
Because it represents true randomness. We can get close to randomness, but there's no such thing as true randomness. You have pseudo-randomness.
How can you not
Okay, so we have different sources of information. You have the spoken word. You go into the general store and you're saying hi to your friends or whatever. You go to church. After church, everyone is chit-chatting about the daily life and what's been going on. You have the written word, reading the newspaper, seeing what's going on CNN.com or whatnot. Body language. In conversation, you can be chatting with somebody, and even though they're saying certain things, they actually mean something else. People here are really bad at this.
Why is that
What?
Why is that thing
Does anybody recognize this?
The slider.
It's the glider.
It's part of a Go board, no?
Why do you have a glider on your slide?
What does that mean?
It's the game of life. Yes, what's the game of life? Anybody?
It's that game that with
Bingo.
the spinning wheel.
The cars with the kids and they go.
Right. Cellular automata, and the idea behind the game of life is that you have basic rules that a system follows. Say there are 3 different rules. Say this piece is right here, and within each state this piece is here. Within each state that this piece is here, put another one here. And you keep going, and you have a state machine that with each step of the state, it adds different pieces and it changes it around. A good example of this could be DNA. DNA as in the base language of humanity, and with each step of time, the person grows more and more, which is the whole idea behind the game of life. Context. How is context important? Context is important. What?
General environmental factors.
Yes, environmental factors. What's going on in your environment completely dictates what you'll be talking about or how you'll react in a situation. You're not going to start a pleasant conversation with a hot chick if there's a fire going on, unless you're insane, or if you want to throw her into the fire.
Those are mutually exclusive? Are you advocating burning women?
Only if they don't
Okay.
have sandwiches.
How the fuck does this relate to reversing? It's probably the question everyone is thinking right now. The idea here is that there is no difference. Understanding the differences between language and those barriers it created are the same barriers that you'll encounter when you're trying to reverse engineer software. What we have here on the left, there's a comic strip. It's asterisk, except that the text is in Latin. Anybody here understand Latin? Okay, 3. Sweet. Most people don't. And it creates a language barrier. And it's very difficult to understand that, although you're able to use context to do so. On the right, we have a hex dump. The hex dump is composed of opcodes that perform different things based on the context, based on the computer architecture. So somebody just taking a look at that, it's going to be meaningless. But if you have context for it, you know what the program is, you know what the architecture is, you know what it's trying to do, you can judge a lot. So to fall back onto the Rosetta Stone, here's a model where you have plain text English up at the top. You have C, the code behind smashing the stack, in the middle. And at the bottom, you have a hex dump. Showing that you can effectively, if it's all about communication, the barriers within that communication, you can have the same ideas being expressed in different ways. Therefore, reading the hex dump or reading the C code or reading the English or French or Latin or Greek or Aramaic or whatever, it doesn't make a difference provided that you understand that and how to overcome that gap and that barrier. Does this guy look familiar?
Bob.
Turing.
He's gay.
I think he's actually dead.
He's gay and dead.
Yeah.
You guys throw him a drink on that.
Anybody know the name David Hilbert? In 1900, David Hilbert gave a talk to, pardon? Okay. He gave a talk to an international symposium of mathematicians. He presented 23 new problems that had not been solved yet. In the interim, many of them have been solved. One of the most important problems that he presented was called the halting problem. And the idea behind the halting problem I have. Given a description of a program and a finite input, decide whether the program finishes running or will run forever given that input. Does that make sense? Basically, you start with the base system, like a chessboard, and you have all the pieces. And given that context and the time that it will run, will it finish running? Yes.
So it's sort of like solving for the last digit of pi.
Exactly.
Or like,
And that's where you get into the ideas of finite versus infinite series. Trying to understand, will something end? Will it keep running? And he published a paper on computable numbers with application to the halting problem. And in this paper, he created the Turing machine.
Woo! Sorry. I'm a Turing fanboy.
Yeah.
I'm pretty sure everyone is.
The Turing machine, every computer that we have is actually basically a Turing machine. You have the tape, which is where we store data, basically ones and zeros or whatever. You know, if it's marked, if it's not marked. You have a mark on a tape versus a blank square. it can erase it, or based on what's in that particular spot on the tape, it can do something. It can move back and forth on the tape, or it can change what it has in memory at the moment. So every instruction within this, there's basically, what can you do? You can write to it, you can read from it, you can move it back and forth, you can store it in memory. Does a computer do anything else?
That's all it does.
Exactly.
It's Turing complete.
Yeah.
As it were. Can you do porn on Turing complete machines?
If you get off the binary, yes.
That's a different.
Now,
Touche.
now, as we were speaking, we have these barriers that one tries to overcome by understanding the context, like talking to a girl. You have to take into account context, body language. You have to understand what she's saying, where she's coming from, whether she's interested or not. We can use that to try to get a date.
This is the happiest day of my life. Hey guys, don't make fun of me, okay? This is the closest to a vagina I've ever got in my life.
It's because of the Canadian lapel pin.
What other types of barriers are there? Within translation, we try to overcome that with the Babelfish, like the Google Babelfish. Everyone probably uses Google Translate. How does that work? It picks out context order of words themselves, and tries to interrelate them to what the French or the Germanic would be. You have tonalities and accents. Trying to overcome those can be very difficult. Anybody here not American?
Shardy.
Shardy?
Not yet.
Accents can be difficult to overcome sometimes, trying to understand the context that a person is trying to relate to you. Say you're on a conference call with somebody who's in Germany or somebody who's in Russia or Australia. Texas. Right, and you have to use all these other properties that these people have to understand what they're saying. And sure, it works in a common sense, but when you actually start to think about it, there are some serious barriers that we've learned to overcome. This also works into things like base systems, binary versus hex versus octal versus base 64, which for context, it's all the same. It's all different representations of numbers, but using them in a different system that will have a different application. People say that computers run on binary, but I don't like reading binary. Hex is much easier to read. Hex is much easier to work with. With hex, you can take the same ideas, but sort them out into much more fine, even patterns. There's also syntactic barriers. So, what are some examples of syntactic barriers? Yes?
I got one for you. There's like a shit ton of books out there in the human language, right?
Mm-hmm.
So you can't really process all of them at once. So that's kind of like a syntactic barrier to the amount of information that you can receive.
Sure.
A lot of it's duplicate data.
Mm-hmm. So the signal-to-noise ratio.
Or people who can read C and like won't even look at Java.
Right,
You know,
right.
It's like, Java.
Absolutely, and code comes into this heavily. Somebody who can read BASIC and is a brilliant programmer of BASIC but doesn't understand C, doesn't know assembly. Do they need to? Right? So you have to take that into context with everything else.
Drink.
Drink.
Money is in the eye of the beer holder.
Does this look, this style of art is called an anamorphosis. It's taking a piece of artwork and then bending it based on refraction and reflection of light. And it's really cool because the way these artists would actually work is they would see an image that they wanted and look at the reflection of it through the glass, through the mirror, and they would recreate it in the distorted image. And you actually, there's a lot of cool stuff. This particular one is called Column 2, but it's basically, the column looks very stretched out and distorted, and you can distort it however you want, provided that you have the key, the opposing piece, that can make it look like something that would fit into a regular context. Beauty is in the eye of the beholder because it's all about perception. It's perception of how we see things. Hex dumps look really odd to somebody who's never even touched computers, but might be an English major, and they know a lot about English. So if you can work that and say, hey, it's all about perception, and you can provide them with information that helps them work in the crossover, then perhaps they will understand what the column 2 really is. It's not that difficult. And that's the point of it. It's all really in just fear. Anybody recognize the quote? What is the quote from?
That's what the universe is on. It's on the turtle.
The story behind the quote was, it's attributed to Bertrand Russell giving a lecture about just life and infinity. And this old lady runs in and she says, what is the universe resting on? Or, well, that was Bertrand Russell was trying to say, what is the universe resting on? So the lady comes in and she says, it's resting on top of a giant turtle, on the back of a turtle. Bertrand Russell says, well, okay, what's a turtle resting on? And she said, it's turtles all the way down. So you have the idea of the infinities there, and trying to understand the different layers of abstraction that we get away from what we view to be real as opposed to perception. For example, here we have this famous Escher piece I'm sure everyone's seen before, where a man is staring into his own reflection. And it's about perception. He sees his perception, but is that barrier, where's the barrier here?
The sphere.
The sphere. What kind of barrier is it, though?
It's a
Round
Okay.
Personality?
He's seeing his own reflection. He's seeing his own perception of who he is, of who the mirror shows him to be. It could be filtered. It could be whatever. But the idea behind the barrier is that the barrier represents a layer of abstraction away from the original source. In this case, the source could be the computerized object, the computerized code that the system sees, that the processor sees. And each step away, each level of abstraction, you get closer and closer to what we could see as like the English language, as basic, as whatever it is you choose to read. Maybe it's brainfuck.
no bullshit.
What are ways to bridge the gap? Translator, sure. What has the work in computer science of the past 40 years been? Nothing? What's AI all about? Anyone heard of Eliza?
Have you heard of OpenFlyBot?
Oh.
It's troll-tastic.
God. But how can we bridge the gap? You could call it digital divide, whatever the hell you want to call it. But the gap between the computer and the human, basically. The Turing test was a great example of this. What? I see the rolled eyes.
Because the Turing test is based on behavior.
Yes?
I could be sitting here reading a book, not moving, not making a sound, right?
Mm-hmm.
Emitting no behavior that looks intelligent, but there's intelligence inside.
Says
right?
you.
Yeah.
Well, you don't prove it intelligence through, say, drawing an abstract piece of art. But since it's relatively abstract and it's coming from your perspective, we can't gauge.
Right, but
or
how?
measure.
But that's not an acid test, right? Because
Exactly. It's formal.
You're right. That's my point.
Indeed.
The Turing test is kind of like bullshit.
I'm not sure
Right.
determines how to measure human
It's a starting point, though.
I agree with you more.
The Turing test is a starting point.
Yeah.
Right. And then when you take all these other ideas and introduce them, what about CAPTCHAs?
They're useless. What else about?
Okay, well, it's a fight
That's
between...
what people in India are for.
Well, don't count
No, that actually exists.
Why are computers so popular now? Why weren't they popular 20 years ago?
Because they can communicate.
Exactly. How can we communicate with them?
Through viruses.
We don't really effectively communicate with the computer, actually. We spend a lot of time...
It doesn't have any idea what I'm
That's not
saying.
true. I tell it what to do and
Botnets.
it doesn't. I feel like it understood me.
Nobody understands me, guys.
We spend a lot of time making computers just communicate with other people.
Right.
You know, if you think about how many times you actually communicate with the actual computer, you really don't spend a whole lot of time
Well, it
figuring
depends on
out
how good you are with computers.
Look
Less
at
good
a
you are,
program.
the more time you spend communicating
A
with
lot of time
computers.
communicating with it.
Right, but the end result is to get it to show that back to a person, right?
Yeah.
Right.
That's just bias.
The computer is, it's a tool. The computer is never your end target, right? It's not a person. You never actually really want to ever talk to the computer.
Well, because it's not
What
a
if I
person.
do?
Right, people want to talk to another person, so you create the computer to look like a person.
Right.
Yes.
You create the computer to talk to you. Because you can talk to
Microsoft Bob. Excellent example.
Ah.
Yeah.
Wasn't that some sort of crappy wireframe house?
No, that's precisely. That's why things like Kismet at MIT's AI lab exist, or the Media Lab, or whatever. Because if people see something that looks like them, then they can relate to it more easily. then you can go back to the bare basics of spoken word oral tradition, overcome those technological barriers, and you can talk to somebody on par in a way that you can relate to. The thing about Eliza, yes, it's talking to a computer, but the author of Eliza wrote a book about it where he said that his secretary tried it out, and she actually, after 10 minutes, asked him to leave the room because she was having a conversation with his program. It's an automated computing process, yet when it exhibits tendencies which are similar to what we're used to and what we relate to other people, we then tend to have more sympathy towards it. Yes. Yeah.
My computer doesn't experience pain.
Every time anybody swore at their computer.
I just swear all the time, though. That's not,
Okay,
How many times have you told your computer you love it?
There's an AI,
There
right?
you go.
We developed an AI in the military. The AI is supposed to figure out who its target is. And they feed it a bunch of pictures, bad guy, good guy, and it's getting them right all in the lab. The second they bring it outside, it starts failing miserably. The reason they figure out is because what happened was all the bad guys were taken on a cloudy day, and all the good guys were taken on a really nice day, so the computer misinterpreted what was right and wrong. We can do the same thing where we draw more information from something than we should, which is kind of how I would say Eliza would work. We're drawing more information than is actually being transmitted.
and every time it rains death from above.
Yeah. That's the best kind of.
Okay, to hop back into the computer side. Ollydbg versus IDA. IDA being interactive disassembler, Ollydbg being just Ollie. What's a debugger versus... Okay, first off, both of these are tools which take hex and what the processor and the computer see and recreate it into an arena that is easier for human to understand. It is a tool. A debugger is something which can take this hex stuff and step through it as if simulating the program was actually running, yet it serves as a piece of abstraction between you and the computer. So you can choose to step through it, you can choose to just run it, you can watch what's going on. It's very useful. A disassembler like IDA will actually take a binary and will restructure the objects which are imposed into the hex structure. Does anybody do much reversing here? Okay. What's the difference between static and dynamic analysis?
Whether or not you're actually running the program.
Right.
So static analysis is limited by your ability to emulate like where the stack frames end up and stuff like that. So you're usually looking for like static patterns in compiled binaries. And then dynamic analysis, usually rather than actually putting logic in your static analysis program to figure out where the stack frames go, it's usually just easier to run something in a jail and see what it actually does. Right?
It would be so hard to evaluate that without context of the actual program.
Exactly.
Actually,
In fact, isn't it mathematically proven that you can't debug an arbitrary program?
Well,
Didn't someone already do that? Like, did we fail already?
Well, there's functional correct and incorrect.
not perfectly,
Hard in the worst
but
case.
we should talk about this offline.
All right.
Hard in the worst case is not the same as hard in the
I just
actual.
read a great paper on that.
Yeah.
Newtonian mechanics is technically wrong, however, it works in most cases.
That's a valid
My
thing.
foot,
So
your
you've got
right.
a functional correct versus absolute.
Sure. An easy example of this, you have a car, right? Look at the car. The car's not running. Look at all the pieces of the car, how they work together. Why are certain features in place? Now try driving the car. It's totally different. You have all these pieces, and they start into this state system of the car going along and along. What if the car gets in an accident? How are all the pieces going to react? You don't know. You can kind of suspect, and you have a basic idea, but you're not going to have the same kind of analysis as you would with static. It's not making one better than the other or vice versa. It's just saying that they are different types of analysis. Of course, my own personal favorite, Ollydbg is free and IDA is expensive.
Except for the free version of IDA, which is free.
And the expensive version of Ollie, which is, what's that company called?
Oh, Immunity?
Yes.
Oh, yeah, Immunity Debugger. Ugh. It has Python support, though.
Is that
Okay.
a selling point?
What? I'm assuming we have enough time? What? I have 5 minutes left? Shit.
What's the symbol at the bottom of your slides mean?
What? I'll get to that in a second. Okay, I can do the Ollydbg demo for anybody that wants to see afterwards, I guess. Getting back to the idea of tools, never be dependent on the tools. Money is a tool of exchange. Don't be dependent on money. Money breeds greed, right?
Are you a communist?
You sound like a communist.
Looks like socio-anarchist.
So,
That's business.
why is it bad to be dependent on the tools? A tool is something that you can use to manipulate other objects, right? But if the tool becomes something that you're dependent on, then suddenly you become the tool of the tool. If you understand how the tool, if you understand how the tool works, you see malfunctions going on with the tool, then you can reverse the tool.
What if you just make a cream for that these days, you know?
Anybody use PEID?
Yep.
Okay, portable executable is the Windows 32, like 32-bit binary system for executables. And PEID is a tool that will take it and it will identify whether it's packed. Pack-in is the idea of like encrypting it or obfuscating it somehow so somebody can't just take a hex dump of it and look and see what's going on. It actually hides it up. So PEID will take that and it will tell you what it's being packed with. So PEID comes with this little database like db.txt or something with all the file signatures, which is the first couple of bits inside of a file that tells you what it should be used. That's actually the marker, the symbol that the computer uses to tell when a file begins, what kind of a file it is and whatnot. So PEID will take a look at that. Based on that, it can tell you what it's been packed with, based on the file signature. So it includes this db.txt file that has a database of all the signatures. So I was looking through it, and it turns out that PEID actually has a completely different set of signatures inside of itself, which do not correspond with the text file that's outside of it, which is really weird because I was looking at some file. I was like, okay, well, this matches up as, whatever it was. It was like a Python, or no, it was like a Delphi file or something. So I looked at the signature of it, and I scanned through the text file. I couldn't find it. So I reversed PEID, and I ran it through, and I found where it was doing it, and it was completely different. So it's not to say that it's good or bad. It's just you can't always be dependent upon the tools. More importantly, if you understand how the tools work, you can also improve them. Cathedral and the Bazaar. So, parting notes, thought manifest symbols.
What's the difference?
Let's go back. What's the difference between thought and symbols?
Good. Yeah.
Okay.
Turtles all the way down.
Turtles all the way down. Right.
If you have thought, do you really need symbols?
A symbol is a way to communicate thought.
It's a very complicated statement.
Yes.
Yeah.
Very complicated.
Also, I think somewhat meaningless.
I don't have enough alcohol with me to have
Dude,
I do. Hang out over here.
And you don't have enough time.
Drink.
This could be a bunch of different things. What's a symbol? A symbol is a stop sign. A symbol is like the red light.
Drink more.
You know what symbols are? What's the difference?
Move on.
Okay. Symbols compose language. You can combine multiple symbols together to express ideas. The more together you have, or the ways in which they are composed, you can express more complex ideas, which represent your thoughts and try to share your thoughts to other people. That's why Greek society flourished, as opposed to Egyptian society, which was based on symbols that represented objects, whereas the Greeks had symbols that were based on ideas and thought structures.
Why is China doing so well these days?
They've got more.
Language is the base for communication. When you take a symbol or a structure or an idea and you encapsulate it within a language, you can then take those words and you can transmit them to somebody else. Communication with the OSI model. Communication barriers can be overcome with tools. So if I'm talking to somebody who's French and I don't know French, I can use Google Babelfish. That's a tool that I can use to overcome that barrier. And always question the tools. So regardless of how reliable you think the tool is, try to understand how the tool works.
Oh, that's French.
Yes, it is.
No, it's not.
The point of this picture, of course. Anybody recognize the Magritte?
Yeah.
Pipe.
No,
What is it?
It's not a plate.
it's not French.
It's a pipe.
It's definitely not.
No.
Ceci n'est pas un pipe?
It's a slide of a picture of a pipe.
Yes. 3 layers of abstraction.
It's a projection of
Put
a
that in
pipe.
your pipe.
It's a projection
Yeah, it's actually a projection
of a computer
It's a reflection
file.
of a projection.
Yes.
So what's the symbol at the bottom?
That's
So what's
Okay, the symbol at the bottom is E.R.I.S. I'm
I've been looking at a picture of a pipe.
E.R.I.S. Research Internet Society. So at that web address, all the materials, because I suck at speaking, so all the materials from this presentation and all the stuff that I wasn't able to include for time concerns is going to be at that web address. So if you're interested in learning more about reversion or symbology or...
Did you copy pasta in your slides?
What?
Did you copy pasting your information from that website?
Sure. Okay. Any questions?
Yes, what does the symbol at the bottom mean?
The symbol at the bottom is the logo for E.R.I.S. Yes?
Why are symbols relevant to signal analysis?
Because symbols help you to extrapolate signal from noise.
So symbol is an arbitrary term. What?
No, symbol is a symbol.
Jesus. Any other questions? Any questions not from them?
So, you know, if I wanted to say do some pattern matching in linear time, you know, would you recommend bioinformatics, something linguistic based, or maybe something using statistics?
All the above.
Yes.
Anything else? That's about it.
Okay.
We can talk later.
Okay. What's your favorite color?
Yes.
Can I go back to the slide of me and the vagina?
Yeah, that was.
Okay.
Is this available on?
On the website.
All right, that's it.
For some
Okay.
I'm sorry.
Is it turned off?
I actually have a German gin since middle school. I can't remember why. I woke up one day, I know what happened. But this stuff is great.
Every microphone I see like that always has electrical tape wrapped around it.
I wouldn't bother with